I'll turn off the light so you can see. Oh, too dark? Was it okay? It's okay, I think. So remove list equals ls as always. Damn it. And that will clear the environment. So first thing that I'm going to do is a while loop. I'm not going to crash R. I don't like crashing R. So, but you see the point on how you can crash a programming language. We did that with Maxima. So let's see, A to be 8, while A is less than, excuse me, greater than 2. What do we use for or in R? A logical or statement. You can either do a single vertical bar, you can also do a double vertical bar. Single, good enough. Likewise, what would you use for a logical and? The ampersand. You can either use a single ampersand or double. So A greater than 2, and I'll use double this time. A less than or equal to 16. Open parent, excuse me, open set bracket, close set bracket, print. Can I use single quotes in R? Yes or no? Yes. Can I use double? Yes. Have to stop. Why? It's an infinite loop. So what did I forget? So I forgot the iterator again. So one advantage in R, when I've run this, it started running, and because of RStudio, there was that sign on the bottom right corner. I'll run this again, why not? You should be able to see, it'll show up right there on the side, stop, click that, and it will stop. Oh, really? Yeah. You probably have some sort of setting. So RStudio has its advantages, a lot of advantages. So you can stop directly. How do I specify the iterator? Now that you've been introduced to Maxima and I taught you how to do the iterator, how do I do the iterator here? A left arrow. A plus 1, Benton's A plus 1. But if I want to make the jumps really fast, if I want to go from 2 to 16, you know, faster than one step at a time, what should I do? A plus 2 or A plus 5? Pick one. So I'm going to pick A plus 4. If you did A, try it at home. A left arrow instead of +4, do A -4 and see what happens. It will hang. So quick jumps, I got 3 values, Tuesday. Good. Just like a for loop in Maxima, we have a for loop in R. And for I in one. So in if you want to specify from A to B as an operator, I'm not sure if I introduced this when we did matrices, but we will revisit that later on. If you want to do 1, 2 something as an iteration, you always use the colon operator. So 1 colon 10. It means I start at 1 and I go all the way up to 10. How many times is it going to print Tuesday? 10. 10 times. Hopefully. There it is. So there are many ways to accomplish this. So the first approach would be to initialize a list using an assignment. So that, what do I mean by that? Well, you can simply start, I could call my list as my.list. I can start with an initial assignment, which is required. You don't give an initial assignment, then you would get an error. So if I put a 0, then my list is not going to have even numbers because 0 is not an even number. So what should my initial number be? 2, okay. And now that I've got that part squared away, for j n, I already have 2. So I'm going to start at 3, go all the way up to 200. And I don't want to use 2i. That is a condition that I gave you. A long time ago, when we were doing arithmetic operators, I said you can do a modular operation using what sign? Percent sign. Remember, if you take a number, for instance, 3, mod 2, what do you expect to get? Percent. Damn it. 1, right? But if I do 4 mod 2, what do we expect to get? 0. So the modulo of an even number is always 0. The modulo of an odd number, modulo 2 of an odd number, will always be 1. So I am going to use that trick, use that arithmetic operator. So if j mod 2 equals what value? 0, because I want it to be an even number. If that is the case, I mentioned we can access elements of a list using square brackets. We did this in script 1, 2, one of those. So I can define the elements of the list using the square bracket. So I have position 1 filled with the number 2. The next position is 2, and I need a value saved there. So I can put j minus 1 . Or I don't want to have T, I'll call it ITR. ITR stands for iterator. I'm going to set the iterator to be 2. In the sense, I'm going to start at position number 2. So the second element of my dot list will now be, I'm starting at 3. So what should I say? Well, when this if condition passes, and if it is an even number and you come inside the body of the if construct, what should I assign here to my list? Print value. I want to say only even numbers to my dot list. I started with 2. What should the next number be? 4. So I'm starting the for loop at 3. So when j is 3, will it enter the loop? No, because this condition will fail, because 3 more 2 would be 1. So skip, it'll go back. When j is 4, is 4 more 2, 0. Yes, so will it go inside the if loop or if constant? Yes. So when it enters, what should I say here? What is my assignment? I heard it. J. Because if j is 4, I want to keep 4. If j is 6, I want to keep 6. So initial iterator position was 2. Now, I can't just leave it as is. I want to grow my list. So I'm going to update the iterator. This line guarantees that each time I add an element, I move to the next position. So initially, I start at the second position. When j is 4, ITR is 2. In the second position of my dot list, I'm going to say 4. Increase the position from 2 to 3. Come back in. I am going to skip, but I'm still in position number 3. When it is 4, 5, 6, I'm going to enter if again, position 3. I'll get 6 saved in position 3. And I'll keep on going. So just to demonstrate, we can always use a paste statement to combine things. So print and paste 0. Call it even entry. Element position ITR. So I start with 2. Once I enter, I'm going to move to 3, and then to 4, and then to 5. And I'm going to keep on going, and I need to go all the way up to 100. So I'm going to run. Bad printing. bad typing. Why do I have an equal sign? So it tells you every time it enters an even number. So the first even entry, 4. That is the only time the if condition will be true. Then 6, then 8. So as I move along, I'm going to save the elements in position 2, 3, 4, and 5. But mind you, what I'm printing is not what I'm saving. If you go back and look at the code, I am printing the element position after I complete the task of assigning. So I assign, move the position, and then print it. So the length of the list is actually 100 and not 101. So length 100. And if I type my dot list, I got the numbers 2 all the way up to 200. That is a list of length 100 with only even numbers. Does that make sense? So I did this in R without using the 2i operation. The reason why I took this approach is because this modular trick is quite often used in programming. Okay. Now, fun part, plotting. Much nicer, I would say. Well, let's plot sine and cosine. Keep in mind, when Maxima did things, it was able to assign limits on its own and create a plot. But when it comes to R, though, you have to specify things explicitly because we're not dealing with expressions, symbolic expressions, rather executable expressions. So I'm going to define my X values. How do I create a sequence of numbers in R? Square bracket. Okay, sec negative 2 pi all the way up to positive 2 pi. I believe the last time I used the argument length, I used length equals 128. This time I'm going to use by equals 0.1. In other words, X will be incremented in steps of 0.1. Good. Y is going to be a sine function, so sine X. Z, cosine function, cosine X. In R, we've got to start with an initial plot. Once we have that canvas, we can put things on top of it. So we need to create an initial canvas. And that can be accomplished using the function plot. Specify X values And the first function, which is sine x, going to make things pretty. So, and to start with color. In R, if you go to the console and type colors, you have about 653 options that you can use, or 657 options that you can use. You can pick a color that you like. I personally like turquoise, so I'm going to go with that. Come again. But unlike maximum, here it has to be within quotes. And that's what you should get. So, because I haven't plotted the cosine yet. All I did was I plotted x and the sine function. I haven't plotted the cosine yet. So by default, R is going to plot points. So if you actually want to have a line, you have to specify the type. So type equals L. Good. That would mean we're going to draw a line. Main stands for a title. I'll just call it trigonometric functions. Main is for the title. Xlab, X label, label for the x-axis. I'll call it domain. Ylab, label for the y-axis. Range. In maximum, I set x minimum and x maximum when I specify the variable. Now I have the color, I have the labels. I just want to make sure the thickness of my line is nice and pretty. So I'm going to do LWD equals 1.25. LWD stands for line width. And that's what you should see. We were able to throw in another curve on top of our sine curve in maximum. I can do the same thing in R. Now, if you use another plot command, it will create a new plot altogether. Think of it this way: you are sketching some sort of an art and you're done with it, you go for another page. So each time you run plot, it is creating a new page. But that's not what I want. I want to draw a curve on top of what I have. So, and also I don't want points, I want a line. So the function here is lines. This time I want to sketch cosine x. So I'm going to use the same x values, but instead of y, I'm going to use z. So x, comma, z. Going to pick a color. Brown goes well with turquoise. Wait, is brown a color? I think so. No, in R, Chris, in R. Yes, yes, I get it. In R. I don't know if it's defined as brown. And I'm going to make this one slightly thicker. So I'm going to use 1.5 instead of 1.25. And lastly, I am going to use LTY. Can you guess as to what LTY could be? Line type. So you can, Maxima can do this also. I saved it for the next time. Here it's easy. LTY, you specify numbers. Number 1, solid. Number 2, dashed, I believe. Number 3, dash and dot. I'll just go for number 3. And that's it.